So we are going to start. So we're running 5 minutes late. We were waiting for the end of the session of the posters, but I think the jury is just finishing, and so we're going to start anyway. So we have our session 3, so Artificial Intelligence for Sustainable Bioeconomy, is shared by Luiz Angelo Steffenel, is professor at the Computer Laboratory in Intensive Computing and Image for Simulation at the university, and is going to share this session. Thank you very much, Steph. I'll take this.
Okay, thank you very much. I don't know if the mic is okay. You can hear me well at the end. Okay, so this session will be a bit special because up to now we had a lot of contributions on biology, on chemistry, geology, and now it's more like computer science and what we can do to help on this subject of a health planet. So I'll start with my presentation, then I have 2 colleagues, one from the academics and other from the industry that will present their contributions, so I'll try to present them in a few minutes. So for this first talk, my idea is to try to show you what we can do, what computer science, and especially what we have now on the domain of artificial intelligence, what can do to improve both let's say, the performance, the efficiency on the agriculture and on other domains, and also on the quality of the labor, because after all, we are also interested in having healthy workers, having people that are they are content, they are fine with their work. And because we are in hands, I will try to introduce some examples on the case of smart viticulture. Well, to start, everyone knows about agriculture, and we know that agriculture is something essential. So from the beginning, agriculture is one of the best testimonies of how technology, how evolution can make things better. If you look, you have the small image from the initial plowing and all the use of animals for plowing to now having tractors, having automatic tractors, having even robot tractors. This shows that technology can also help us to produce more and produce better. This is true because we all depend on it. Without agriculture, we are nothing. We cannot eat, we cannot dress. We have a lot of completely dependence on the agriculture. And the truth is, it's always and will always be a problem. If we think that in like 20 years from now, 30 years from now, we probably will reach 9 billion inhabitants in the planet, the need for resource is important. And also because most countries are now going to a developed level, the need for products, the need for food, the need for goods is higher than before. So we need not just to raise by 10% the performance of our production, we have almost to double this. The point is, because agriculture is so important, we also see a change that is partly made because of the technology. Okay, just ask you to sorry me because of this bad image, but I could not find the best one. It shows in green the surface of cultivated lands compared to the number of workers. And since the beginning of the last century to a few years ago, we all see that we even increased the area, we increased the surface of planted area, but the number of workers has reduced by like 4 or 5 times. Well, how this could be possible? Because we really invested in the last century on automation, at the start just to make things, to compensate the loss of workers, because a lot of people migrate to the cities. There is this rural exodus, but also to try to improve the quality of the work. So, more like this. Oh, Sorry, that is why I asked before. This way. So in the last 10, 15 years, we heard a lot about smart agriculture. What is smart agriculture? The truth is, it's not one thing, it's an ensemble of domains that converge to help agriculture. First of all, we have the idea of having sensors, Internet of Things sensors, IoTs, satellite data, everything that relates to gathering information, gathering data, because before we had some kind of traditionalism or sometimes the experience, someone that worked like 30 years in the farm, he gathers information, he learns from his father, from his grandfather, but now we can gather information, we have this possibility. So try to use information to make farming, to make agriculture better. Also, there is a huge potential for this automation. If you think in the United States, at least 80% of the farmers, they use some tool related to smart agriculture. Sometimes it's just a small help, a small data sheet that they can use to fuel a farm. In Europe, it's about 25%. So we have a lot of work, we have a lot of margin to improve our usage and our efficiency using smart agriculture. But, okay, we have nice pictures here. What is really smart agriculture? The truth is that you have at least 3 domains. The first domain is related about decision-making. So when you think about decision-making, you have all this data gathering. You have to collect information, you have to show this information, so visualization of data, and also try to help the daily activities. As I said before, it can be just filling a form saying, okay, today I have spread this pesticide on this zone. This is one simple thing that can be part of what is called smart agriculture. We can also think about precision agriculture. This is a small different domain where we try to use the information before and gather other information like GPS, drones, robots, and so on, to do what? To act on the field using a precise thing. For example, try to spray a zone only when there is the need, only when there are some disease, not to do this everywhere. And the third one, that's almost a consequence, is to do some automation. So be it using a tractor, be using it a robot, a drone, whatever, anything that can replace some tasks, replace some manual work, perhaps doing it better, perhaps just doing it instead of a repetitive task that really is hard for the worker. So we can have here, for example, some examples. If I am a farmer, when my crop is growing, I'm interested, for example, to know how much I will produce this year. Of course, it changes from year to year. Last year there was a lot of rain. This year is dry. How much can I expect to have at the end? I can also want to predict which are the diseases I will be subjected. Perhaps with the climate, like the time like today, I will be more fungi, more things like this. After harvest, I'm perhaps interested in knowing, okay, did the quality achieve what I asked for? Are my buyers interested in my product because I got this quality? Also, the quantity is like before. Try to imagine how much was the yield. Also, the industry is interested on tracking, and more than ever, we are really interested on knowing from the farmer, from the producer, to the final consumer, all the path, all the chain that lead from the field to our plates. So also we are interested on this quality tracking about transportation, about storage. So what we can do? The problem is, let's say for the last 10 years, people that are working on smart agriculture, they have been flooded with hundreds of products, hundreds of companies that try to sell them solutions. As I said, the first thing we did when we started doing smart agriculture was to collect data. But just collect data is not enough, because too much data, it's really hard to learn, it's hard to interpret. I'll give you an example, satellite data. I think that most of people here that work on plant biology, they know this index, NDVI, next infrared. It's really nice because it's one of the oldest index that you use to detect the hydric stress on plants. But if you use NDVI, it depends a lot on the weather. It's cloudy. You have a direct sun, you don't have direct sun. So over the years, researchers developed different index. And here we have just a small catalog of things that you can get from satellite service. But if today someone gives me, okay, here you have a chart, you have a map with your fields, with your parcels, and an index. It is enough. How can I interpret that this red spot is a problem, or is just something that I must watch? So the problem is, just have information is not enough. And that's why the new smart agriculture tried to put knowledge where before we had only information. So there's a difference between information and knowledge. So AI is one of these tools. We can use artificial intelligence to try to interpret, try to give a direction and give a decision-making, like say, a small counsel about how to interpret this data. So I'll try to bring you some examples. But before this, for people that are not so used to what is artificial intelligence, let me make a small course. First of all, it's perhaps an error to say we are doing artificial intelligence. The truth is that the word artificial intelligence is like a big domain that relates to everything that could be related to simulate the human thinking. The truth is what we heard, what you see now, even ChatGPT, it's not fully artificial intelligence. It's just a small subset that in our domain in computer science, we call machine learning. And machine learning is try to do some algorithms, try to do some methods to make the computer learn from data. That's the point, learn from data. Truthfully, we can say learn from example. Instead of developing models, developing formulas, we feed the algorithm with a lot of data saying, okay, this is something, this is another thing, and now it's up to you to learn what bring to this decision to the other one. So things that you can do usually in machine learning are, like say, 3 types of things. Try to do classifications, separate elements, try to do regressions, that means try to predict a value, or try to find, making clustering to find difference, find groups among these elements. Inside this machine learning domain, there's one thing that is really what we tried to do in the last few years. It's called deep learning. Deep learning is one family of algorithms in machine learning that is dedicated to try to use what you call neural networks. And it has an interesting characteristic because with neural networks, we can feed a lot of data in the form of images, in the form of text, in the form of audio. So it's not just about numbers, it's about different forms of information. And what is also interesting is that if before we are more on the learn by example, here we can do an automatic pattern detection. So we don't need always to say, this is a cat, this is a dog, or a rabbit. You can have some kind of auto detection of patterns. So let me just close this part and go. So what we can do now with all the data we have in smart agriculture. For example, we can do image analysis. everything that you can put a camera or you can transform an image can be used. For example, a satellite image is something that you can do. We can also try to use data from sensors. We have now a lot of sensors that we use every day to record the temperature, to record the humidity of the soil, to record the wind, the rain. All this can be used as data. We can also put all this data in a timeline. And so we have time series that can allow us to predict or to see what variations we have seen over the years, and perhaps what can happen next year if I have conditions like 3 years before. So all this is possible. But most than all, most important than everything, we need an objective. None of these algorithms, none of this data are interesting without an objective. So if you want to do something, let's work towards this objective. If you have an object and you have sufficient data, we can do this. Another question, what it costs to train? Because of course it's not for free, but it's not that hard as people say. Of course, using again ChatGPT, it's a huge example and it takes a lot of resource to train. But the truth is, we need data and we need to find out some resource for training. It can be, of course, accelerate if you have a huge equipment. Here I put some image of our supercomputing center at the university. It's a nice tool to accelerate things. I can do almost the same thing in my own computer, but it takes 10 times more, 20 times more. It's just a way to accelerate. The truth is that the more data you have, the more complex is your objective. It takes more time, but it's normal. We are making exponential analysis on everything. The bonus part is that now we can reuse a lot of things, especially in the use of image analysis. We can reuse models, so we don't need to start from zero. That's the best part. We don't need to, for many users, we don't need to restart from zero. And when you have a model that was trained, it's important to know, can I run it? The truth is, when you have something that was finished, when you have a model that was trained, you can run it almost everywhere. I'm sure all of you have some kind of artificial intelligence in your pocket. Because the truth is, in our phones, we have a lot of AI algorithms that are already running. And, oops, sorry for the image, cloud computing is also an option. But in the case of a smart agriculture, we don't want to send data, we don't want to rely on a distant platform. Sometimes it's just because you cannot contact them. Sometimes you don't have the network, you don't have even a 3G phone connection. So a lot of work has been done in the last years on what is called edge computing. We can put all the models that we're training on big machines on small computers that can be installed everywhere. So now I will try to show you some examples of things that we have done on the sense. So, as I said before, our objective is to show things that have been done in this region, so related to viticulture. And in the case of Champagne, because we have this specialty, Champagne is a domain that has a lot of restriction. The truth is, to work with people that do Champagne, they have a lot of tradition, they have a lot of rules to respect, and it's not easy to innovate. But it's possible because we can try to help them to improve, of course, the performance, but also improve the quality of the work. One example. Every producer wants to know how much I will produce at the end of the year. The truth is, today, if you ask one producer of Champagne, one vineyard, they will say, okay, our system is, I try to do samplings in some parcels, I count how many grapes I have, I multiply by the number of plants, and I have an average expectation for the future. Part 1, it's a sample. Sampling means I have a huge error. Second, there is someone that needs to go and count. If you do this, you have an error margin, and you are making someone do a repetitive task, because, please, it's not easy to count plant by plant how many grapes you have. Can we do this better? Can we do this in an automatic way? So this is, for example, one part of the contribution we had in a project. We simply added a camera to a tractor and tried to count how many grapes there are in the vineyard. So let me just show you a small video. Uh-oh, okay. No, seriously. What happened? Okay, don't worry, don't worry. No, it was... No, it's my fault. I don't know why it didn't show the good part. I cut. Okay, what you should have seen was a video where we pass and you have all the grapes being surrounded and counted. So we can count in real time the number of grapes in the field. If you do this, you can do a map showing the density of the products. You can also just simplify your prediction, because you now have the exact number of grapes you have in this field, so you can just multiply by the average weight. All this during the labor, so a camera, in a computer, in the tractor, no one doing this, it's just during the regular labor. So the workers are fine, they're doing what they have to do, and at the same time, we keep this information. We can go even further. For example, we can try to see how many grapes were counted compared to the real number of grapes. Because of course, there is always some grapes that are behind leaves. They are hidden behind leaves. There are some works, it's not, we didn't do this, but there are some works that try to even estimate the volume of the grapes. They do a post-treatment to see how many spheres they can see and try to estimate the size of the grapes. These are things that we can do by artificial intelligence. Another example, this time it's not from us, it's from IIT and Pisa in Italy. They are interested on reducing one part of the work, that is the pruning we have to do during the winter. Well, pruning, it's a repetitive work, because how many plants you have to prune, and usually you do this in winter, so in harsh conditions. So what they did, they trained algorithms to identify each part of the trunk, and they developed a small robot. For them, they are doing this only in lab. They developed a small robot to cut, to prune automatically. So the idea is to do this in a regular way, day and night. You don't need to think about the conditions of the worker. You don't even need skilled work, because if you pick someone that has no skills, he will literally cut out the trunk. So that's one contribution. Let's see another thing. Control diseases. Well, how many of you know, for example, the downy mildew incubation cycle? All the works today, they try to do estimation when there will be my first infection, when there will be take place my second infection of mildew. They are based on works that established in 1936 that set specific conditions. I need that amount of rain, this temperature, this wind more than meters per second. So you have strict rules for this. Well, for sure it works, but not always. Sometimes, in two parcels that have the same conditions, apparently, they are subject to the same conditions, you have infection in one and nothing in the other. So that's the question. Why these fixed conditions have been set? Cannot they be more flexible? Perhaps I can see, in my case, this year I got an infection. Next year I don't have an infection. What changed? Which factors have changed? So instead of just relying on simple conditions, I can try to use everything that sensors give me. Today you have sensors that give you a lot of information. Amount of rain, humidity, dew point, temperature at the base of the plant, temperature 10 centimeters under the soil, and so on. So try to use all this and use AI to, in this case, I got. In this case, I don't got infection. And perhaps you can see, okay, in my case, in my plant, these are the conditions. They are perhaps not exactly as before, but now I know that next year, if I have the same conditions, there are more chance to have this. Another one, assessing the quality of the grapes. Well, farmers don't like to see this, but people that transform grapes, they have to do this. They have to check when the grapes arrive, do I have good grapes? Do I have grapes that are bad, sick, or just parts that are not grapes? Perhaps some leaves, some parts of some stones, and something else. So today, when your grapes arrive at the pressing site, there is someone that do some checks. Of course, they do some physical checks, some chemical checks, check about the amount of sugar, the acidity. But also they do a visual inspection and say, okay, in this case, I think it's okay, grade A. In that case, I think it's not good, grade C. Grade C goes to vinegar, grade A go to champagne. But in the morning, I can do this quite easily. Will I give the same judgment in the evening? So, not sure. So instead of doing this repetitive task that implies some subjective analysis, for me now it's okay. The same crate in the evening would not be okay. We can try to automatize this. So this again, we did some work to identify bad grapes in the crate and give an answer. So I hope this time the video will play. Oh, go. As you said, it's not easy. With the try one and go. So this is one example that we even went to production site. So we developed all things. We trained on the supercomputing. We put in a small device that is installed on the pressing site. So we start training on the supercomputer, and at the end we have this box that's completely autonomous, installed on the thing side. Of course, you need to got a lot of data. So over 3 years, we collected like 3,000 images. My people over there, they circled every bad grape. And at the end, we have like this. We have an interface. So we take a picture, and now it gives you a grade. So, well, we can see perhaps here, we have some zones that are identified as the bad grapes. So we can have this to grade the grapes, but also to have some kind of post-analysis. If someone says, okay, I don't understand why you said my grapes are bad, okay, look in these pictures. You have some audit also to do. Well, perhaps we know now that the AI can have some impact. The truth is always try to do something useful. So for sure, nothing is interesting if it has no business interest. The truth is, anyone that tries to introduce some new techniques, they are interested in doing something to improve their business. So the truth is this. Everything is trying to make your business better, trying to make your products better, try to do something. And if you can have a good impact on your workers, that's better. So not always think that AI can solve everything. As I said before, when you do AI, we need an objective. There's no magical solution that will give you the answer for everything. It's not 42. Sorry for the computer science joke. The truth is, everything that we do, so we need a decision-making tools, an automation tool, but we need for something that was specific. You can only do one thing at a time. Even the most complex algorithm, once again, ChatGPT is not a no powerful algorithm. It's something that was made to talk with you, nothing else. It's not capable of looking at an image and doing something. So even if you have this, if you have an AI, it's for an object. So all the idea is you need a business, you need data, you need a goal. And we cannot remove people from the play. It's impossible to completely remove people. You can replace people where things are hard to do, but there's always some specificities. And especially when you're talking about plants, plants are living things. This year, for the last 20 years, they show nothing special, and then next year, they do something unexpected. They are living beings, and they can do unexpected things. So we have also to be humble. When we do AI, we are dealing with living things. So what we can expect now? Over the last year, we saw, for example, here in the region, a lot of talk about autonomous robots. I think I saw like 3 or 4 new models only in the last month in the journal. Autonomous robots are nice, but I'm not sure that we'll see them so often as this. Why? Because legislation, for example, is something really strange. In France, we cannot have a robot that goes completely by itself. You always need, especially if you have a big tractor, you always need someone close because in case of problems, you have to have a responsible. In case of, you cannot even cross a street with one of these big robots. You have to keep them in one single parcel. So perhaps fully automation with robots, it's nice, it's good to showcase, but it's not the future. However, everything related to gator data, images, meteorological data, sensors on the field, even agglutinative satellite data with aerial data, this has a good future because you can develop tools, you can develop assistant tools, you can develop decision-making tools, and perhaps I believe this is the part where people will really gain in the next future. Also, just to finish, you have, of course, some ethical impacts. Using AI everywhere, one day or another, people will say, okay, it's not champagne anymore, it's some industrial thing made by AI. So for sure, will be regulation, will be some kind of breaks to keep this artisanal way of doing. So we also have humans over there. Nothing can be completely automatized. That's it. So, well, let's say AI is there, artificial intelligence is there. It's fun. You have a lot of opportunities. It has made some sense on all this amount of data that you had from the first smart-viticulture wave, but it's only interesting if you can automatize some things, so repetitive tasks or a bad condition work. This is interesting, but especially try to add value to your products. Without this, AI has no interest. So don't think about AI as just a toy. AI is a tool. Without users, a tool means nothing. Okay, so thank you.
So thank you very much, Luiz Angelo. So I will moderate the question as the questions are for you. Is there any questions in the audience?
Hi, Angelo, and thank you for the talk. I was just curious, very naive question. When you take the picture of the grapes, you only see the surface of the box, right? So how can you analyze the whole quality?
Okay, just to tell you that was really a constraint we had to work with, because in the case of Champagne, you are not allowed. They don't want you to move grapes a lot. Everything that you do with the grapes can hurt the grapes and then taint the wine. So we have no right to check under the grapes, for example. So in our case, what we did was a statistical analysis. We really, for a few grapes, we open everything and you count how many grapes were really on the box compared to what was visible. And because they were in the same amount, for the moment we check, we say, okay, what is visible? It's almost the same you can see in all the crate. But it was a constraint. There are some other wine producers that they have I don't know how to say, tapis. Okay, so we can take pictures grape by grape, but in the case of Champagne, we had to deal only with the surface. I know that there are some other works that try to use, for example, hyperspectral analysis. You can see a bit lower, let's say in depth, but then there's the problem of all the calibration of hyperspectral, so it's not easy also. Anyway, you can do X-ray on your grapes to see if there's something, but I don't know if it's good for the appellation.
Yeah, it's very interesting. I was curious if you also think about letting your models evolve as you're collecting more and more data now. You may have a great data set you never had at the beginning. Yes. And climate is changing, so you might see patterns and things evolving. So are you looking into that as well, or not yet?
That's a good point about Champagne. And perhaps what we present here was mostly was the result of a 3 years European project that stopped last year. And now we are in the second project, continuing this, and we are moving to the production part. So, for example, following the Champagne, already following the fermentation process, and also following after all let's say the chain of production, all the bottles, how they are stored. So this is part of the thing. The good part of Champagne is this: we can have a test case in the field and test case on the shop selling the Champagne, because most of the chain is controlled. It's different from another wine that when it leaves the cellar, you have no control anymore. So it's